Imagine a world where the sun dominates the sky, a planet so close to our star that it experiences the most extreme temperatures in our solar system. Welcome to Mercury, the mysterious planet unveiled. Mercury is a fascinating planet. It is the smallest planet in our solar system. This tiny world is also the closest planet to the sun. This makes it a difficult planet to study. However, scientists are learning more about Mercury all the time. They use telescopes and spacecraft to make new discoveries. In this essay, we will delve into the mysteries of Mercury. We will explore its size, surface, atmosphere, and extreme temperatures. We will also examine its unique orbit and rotation. Finally, we will discuss the leading theories about its formation and the insights gleaned from recent missions like Bepi-Colombo. Mercury is much smaller than Earth. It is only slightly larger than our Moon. This makes Mercury the smallest planet in our solar system. Despite its small size, Mercury is a very dense planet. This means that it has a lot of mass packed into a small space. The surface of Mercury is very similar to the surface of the Moon. This is because both bodies have been bombarded by asteroids and comets for billions of years. These impacts have left Mercury's surface covered in craters. Some of these craters are very large. The largest crater on Mercury is called the Caloris Basin. It is about 1,550 kilometers in diameter. Mercury has a very thin atmosphere. This atmosphere is so thin that it is almost non-existent. Scientists call this type of atmosphere an exosphere. Mercury's exosphere is made up of small amounts of gases like sodium, potassium, and helium. These gases come from the solar wind and from the planet's surface. The surface of Mercury is a harsh and unforgiving environment. However, it is a fascinating world that can teach us a lot about the early solar system. Mercury's orbit is very different from the orbits of the other planets in our solar system. Most planets have relatively circular orbits. This means that they stay about the same distance from the Sun as they orbit. However, Mercury's orbit is highly elliptical. This means that its distance from the Sun varies greatly during its orbit. At its closest point, Mercury is only 46 million kilometers from the Sun. At its farthest point, it is 70 million kilometers away. This variation in distance means that the amount of heat and light that Mercury receives from the Sun also varies greatly. Mercury also has a very slow rotation period. This means that it takes a long time for Mercury to rotate on its axis. In fact, it takes Mercury 59 Earth days to complete one rotation. This slow rotation period, combined with its short orbital period, means that one day on Mercury, from sunrise to sunrise, lasts for 176 Earth days. The combination of Mercury's slow rotation, its elliptical orbit, and its lack of a substantial atmosphere leads to some of the most extreme temperature variations in our solar system. During the day, the side of Mercury facing the Sun can reach temperatures of up to 430 degrees Celsius, 800 degrees Fahrenheit. This is hot enough to melt lead. However, at night the temperature on Mercury can plummet to minus 180 degrees Celsius, minus 290 degrees Fahrenheit. This extreme temperature difference is due to the fact that Mercury has no atmosphere to speak of to trap heat. Scientists have developed several theories to explain how Mercury formed. One theory suggests that Mercury formed much farther out in the solar system and then migrated inward to its current position. Another theory suggests that Mercury was once a much larger planet that was stripped of its outer layers by a giant impact. Recent missions to Mercury have provided scientists with a wealth of new information about this enigmatic planet. One such mission is the Bepi-Colombo mission, a joint mission between the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA. Bepi-Colombo was launched in 2018 and is scheduled to arrive at Mercury in 2025. The mission consists of two spacecraft, the Mercury Planetary Orbiter, MPO, and the Mercury Magnetospheric Orbiter, MMO. These spacecraft will study Mercury's magnetic field, its interior structure, and its surface composition in unprecedented detail. Scientists hope that the data collected by Bepi-Colombo will help to shed light on some of the mysteries surrounding Mercury's formation and evolution. For example, they hope to learn more about the planet's unusual magnetic field, which is thought to be generated by a dynamo effect in its liquid iron core. The study of Mercury is important because it can help us to understand the formation and evolution of our own planet. By studying the similarities and differences between Earth and Mercury, we can learn more about the processes that have shaped our solar system